Okay, a radioactive material has a half-life of 6 days. How long will it take for 75% of a pure sample of the material to decay? Alright, so this material, I can just label this as X. Okay, whatever that material is. And I know that when it undergoes a half-life, which takes up a period of 6 days, okay, that is now going to be expressed as X over 2. Because again, recall what half-life is. You're taking the time it takes for the material to decay in half. And the problem is telling us that it will take 6 days for this to happen. Right? Now, if you just continue this process, okay, let's say after 6 days, I'm already at X over 2. It's going to undergo half-life once again. Alright? And then, because it takes 6 days for that, I know that this will be another 6 days. Okay? But what will my new value be, the amount of the original material? How will I express that? Okay, well, if you know the patterns for half-life, that is just going to be X over 4. Okay, because you're going to half this. It will give me X over 4. So after 12 days, I actually have this amount. Now, the question is asking, how long will it take for 75%? Okay, well, we know that from here to here, this is clearly 50% because it's half-life after all. Okay, and you could argue that if I were to just limit myself to these two parts here, X over 2 and X over 4, that is also technically 50%. However, how do I know the percentage at this portion? I always compare it to what I had originally. So from this point to the original amount that I had, that's 50%. But by the time I reach this part, how many percent is that? Is it still 50%? It's no longer 50% to the original. In fact, it's half of half, which means that this is actually 25% of what I had initially. Okay, so now as you can see, that's going to be 50% plus 25%, giving me 75%, which is what I want from the problem. And how many days did that take? It took me 12 days, and so the answer is letter C.